folks, to another exciting AP Chemistry video. We are looking at 4-1. Yes, Unit 3 is finally over, but I know how disappointed you guys are to be moving on from that riveting and exciting unit. Do keep in mind that was worth 20% of the AP exam, so 1 out of every 5 questions is going to come from that. To be perfectly honest, you guys did a really good job. You rocked that, so I'm very, very pleased and looking forward to some much shorter units coming up over the next several months. This one is no exception. We're going to be talking about chemical reactions this unit, and to just get us off to a really good start, we're going to start with just basic chemical reaction ideas and concepts, some stuff about net ionic equations, and representations of solutions, and representations of equations. So hopefully by the end of this video, you will be able to differentiate between chemical reactions and physical changes. You should be able to balance chemical equations, evaluate equations for the calculation of the net ionic equation, and also to be able to evaluate sources of error for a variety of reactions. So when we talk about the differences between physical and chemical changes, it seems very, very basic, but there are some subtle nuances that I want to make sure that you understand that may be asked by the AP exam. Physical changes occur when a substance undergoes a change in its properties but not in composition. That is, the chemicals do not actually undergo any type of change. You don't form any new chemicals. So with physical changes, we're looking at things like changes of phase, things like freezing, melting, vaporization, condensation, sublimation, deposition, things along those lines. Or the formation or separation of mixtures, things like dissolving salt into solution. That is a physical change, not a chemical change, because we really aren't altering the chemical composition. We're not really forming new chemicals as a result of that. Or for example, the evaporation of water in solution. If you have salt that is in solution and you boil off the water, you get the salt back. It is a physical change, not a chemical one. Chemical changes occur when substances are transformed into new substances, and the identifiers for this would be something like a production of a gas, the production of heat, light that comes from a reaction, formation of a precipitate, which is a solid that forms in solution, color changes, etc. So be sure to keep those things in mind about the differences between a physical change and a chemical change. So I know those will pop up in some of the questions that you will get. Now, physical changes typically result in the changes of the intermolecular forces that are present. So take ice, for example. Let's just take liquid water. Liquid water, as you know, those molecules are very, very close together, and as a result, they have very high intermolecular forces. Well, if we were to boil that water and turn it into steam, we're not breaking the covalent bonds that exist in the water molecules themselves. We're breaking the intermolecular forces that are holding those water molecules together. So do keep that in mind, that when we talk about physical changes, many times we're just simply breaking the intermolecular forces that are holding the individual molecules together. Chemical changes typically break and reform covalent or ionic bonds, unless it's going from a solid being dissolved into solution. That's actually a physical change. So when we talk about a chemical change, we're actually breaking the chemical bonds that hold the individual atoms of the molecule together. And as a result, we get a different chemical at the end. So that would be a chemical change as opposed to a physical change, where we're just simply breaking the forces in between the molecules. Now, since we're talking about chemical equations, I think it's important to talk a little bit about the conservation of mass. And that simply states that the amount of matter does not change as you go through a chemical reaction. The amount of atoms that you start with needs to be the same as the amount of atoms that you end with. And therefore, you must balance those chemical equations using coefficients. You cannot change the formulas, but you can add coefficients to the front in order to balance them out. Now, you guys are AP Chemistry. You guys have been doing this for 2 years. I suspect you guys are probably in pretty good shape on this, but some of the chemical equations we're going to look at are going to be a bit complicated, so I just wanted to remind you of this fact before we move forward. Now, something that's probably the most important part of this unit is being able to identify and work with net ionic equations. Now, these are equations that are based on normal chemical reactions, but only represent the species that underwent a chemical reaction. So you really want to look for phase changes as a result of this. Take a look at all of the equations below. All of these are aqueous solutions, or solutions that have been reacted with one another, and you notice that they're AQ. If something is listed as aqueous, this is really important, they are dissolved in solution. They form their ions as a result. And so if you were to write the ionic equation, you would actually break these down into individual ions. So for the first one there, you'd see Ag plus NO3 minus, all of those would be aqueous, plus Na aqueous plus Cl aqueous yields AgCl is a solid. Okay, that is a solid compound, so we can't write that as aqueous. That is something that forms at the bottom of the solution. It is a precipitate. Plus Na plus NO3 minus, because they're aqueous. And so when you write the net ionic equation, you look for what has changed, what actually underwent a chemical reaction. In this case, Ag and Cl formed AgCl. Those are the only species that actually underwent a chemical reaction. So all of the other ions are what are called spectator ions. They're called that because they actually don't participate in the chemical reaction. So look for this when they're forming ions. Also look for the formation of water as well, particularly in an acid-base chemical reaction, because your acid is aqueous, your base is aqueous, but remember that water is not aqueous. Water is a liquid. So that would be something you would want to include in your net ionic equation as well. This is something we're going to practice with quite a bit as we move forward, but I just want to make sure you keep those things in mind as we start this next unit. And then lastly, be aware that diagrams can be used to represent chemical reactions. And so we did a little bit of this in our last unit. If you look on the left-hand side there, you have an unbalanced particulate representation of a chemical equation. So you may have to go through and balance those, or you may want to look at the number of molecules that are produced, or whether something is a gas that is produced, because that can have an effect on ideal gas law and temperature and whatnot. On the right-hand side here, you want to look at a solution-based problem. Looks like we have some sort of potassium compound that was mixed with some sort of calcium compound, and as a result, what we get is calcium carbonate, which is a solid. So you need to make sure that you're aware of some of your solubility rules. Hey, quick little short video for today. I hope you guys get the gist of what we're focusing on. Like I said, make sure you understand those differences between chemical reactions and physical changes. You need to be able to balance chemical equations for this part of the unit. Net ionic equations is going to be very important. And then we'll talk about some of those sources for error a little bit later on. Hope you have a great day, guys, and we will talk to you later. Bye-bye.